Laser is invisible light, but after focusing, its energy becomes extremely strong. See, I've turned on the switch now. You can't see the laser, right? Watch as I put this cardboard down. It catches fire. Let's try metal. Okay. The metal catches fire too. Today I'll explain the working principle of the handheld laser welding machine. Once you know the principle, you'll know how to use it, and also know how to recommend it to customers. Actually, its principle is very simple. This is the welding head of a handheld laser welder. This is a schematic. The optical fiber comes from here. There's a fiber cable. This yellow one is the fiber cable. This is the main unit with the laser inside. The laser produces the laser beam. Through this optical fiber, through total internal reflection, it's transmitted through this fiber to this point. This is the laser beam. There's a collimating lens here, approximately at this position. During transmission, the light is divergent. The divergent light is collimated by the collimating lens into parallel light here. This is a reflecting mirror. The mirror reflects it down. It refracts to this point. This is a focusing lens. After focusing, all the laser beams converge here. This is the focal point. As kids, did we ever use a magnifying glass in school? A convex lens placed under sunlight. We used to play and burn ants. I don't know if you've tried it, but we post-80s generation all played that. The principle is similar. A convex lens focuses light. This is also a convex lens. Focusing into a single point, this point has the strongest energy. That is, this point is located at the welding nozzle. After laser focusing, it melts the base material or welding wire to form a weld bead. So the principle of handheld welding is to focus the laser beam from the laser to produce immense energy. But, after focusing, the laser is just a point. But with a single point, if you want to weld a wide bead, like a 3mm or 4mm bead, how do you achieve that? The thinnest welding wire is 0.8mm. The spot size after focusing is about 0.5 or 0.3mm. That spot is very small. Then, through the motor inside, there is a reflecting mirror mounted on the motor. The mirror changes the direction of the light. Because the mirror oscillates back and forth, right? Changing its direction, forming a wide weld bead. This line is it. The motor oscillates, driving the light spot to sway back and forth, forming a wide weld bead. This bead is about 3mm wide. After I lower the oscillation frequency of the motor, you can see the light oscillating. When the frequency is high, so it appears as a straight line. Now I lower the frequency. Let's look at the scanning speed. I set it to the minimum. The minimum should be 30, isn't it a point oscillating back and forth? Actually, after focusing, the laser beam is just a point. So if I increase the frequency, it oscillates back and forth continuously. When the speed increases, it forms a line, right? The naked eye cannot see it,